Good afternoon, everyone. The title of our paper, An Engle-Granger and Johansen Cointegration Approach in Testing the Validity of the Fisher Hypothesis in the Philippines. Interest rates and inflation are two important macroeconomic variables as their behavior have a huge impact on economic growth. Better knowledge about the link between interest rates and inflation is crucial for the efficient and timely economic decisions specific to monetary policy. American economist named Irving Fisher proposed that nominal interest rates behave positively with inflation in the long run. Fisher in 1930s tested this relationship for the UK and the US and found strong correlations running from the changes in inflation to the changes in nominal interest rates. It appears that in the long run, Fisher effect is more obvious simply because interest rates are highly random in the short run, hence they have no significance in predicting inflation. At macroeconomic level, interest rates affect savings and investment spending, which may interrupt economic growth. Thus, it is important for government policymakers to have better understanding about what drives interest rates. As interest rates are important determinants of savings and investment spending and therefore crucial to economic growth, the Fisher hypothesis has important policy implications for the behavior of interest rates and the efficiency of financial market. Inflation targeting brings sanity within the financial market. Monetary authorities can allow inflation, while the interest rates can be used as a monetary tool to achieve the targeted inflation level that will positively impact economic growth. An important element for the successful conduct of monetary policy is the ability to manage inflation. For instance, it is crucial that inflation expectations are well anchored, as this allows central banks to achieve price stability while helping at reducing interest rates volatility. Currently, the Bangko Sentral ng Pilipinas and most central banks have espoused inflation targeting as their monetary policy framework. Under this framework, the Fisher hypothesis is of essence because interest rates can be used to target and control inflation uncertainties, and inflation targeting enhances BSP's monetary policy credibility because it promotes transparency, accountability, and good communication strategy. In this paper, we applied Engle-Granger of 1987 and Johansen of 1991 co-integration approach to test the true dynamics of nominal interest rates and inflation under the Fisher hypothesis framework. It is applied for a lower middle-income country like the Philippines with monthly data on the nominal interest rate measured in terms of the 91-day Treasury bill rate and headline inflation ranging from January of 1995 to 2020. For the methodology, according to the Fisher hypothesis, the relationship among real interest rates, nominal interest rates, and inflation. Since nominal rate of interest is the sum of real interest rates and inflation, it follows that increases in inflation will increase the nominal interest rates, while real rate of interest will remain unchanged. In fact, there is one-for-one adjustment of nominal interest rates to changes in inflation. This study examines the validity of the Fisher hypothesis by employing co-integration techniques such as the Engle-Granger 1987 approach. The Engle-Granger approach involves two steps. First, a static regression model is computed. Then, an auxiliary time series dynamic regression is run to test whether the residuals from the static regression are stationary. On the other hand, Johansen of 1991 and Johansen and Juselius of 1990 have constructed a maximum likelihood approach for estimating alpha and beta, as well as the likelihood ratio tests for detecting the number of significant co-integrating vectors. There are two statistics from the Johansen vector autoregressive tests that determine the rank of the co-integration space. The likelihood ratio tests based on the maximum eigenvalue and the likelihood ratio test based on the trace statistics. The procedure is based on a vector autoregression of order P developed by Johansen. In addition to testing if nominal rate of interest and inflation have a cointegrating relation, the cointegration vector beta, which is equal to 1, is checked using the equation. If beta, which is equal to 1, the nominal interest rates moves 1 for 1 with the rate of inflation in the long run. That is full Fisher effect. If beta is less than 1, it is known as the partial Fisher effect. Granger causality tests was also used to determine the direction of causality as expressed in equations number 7 and number 8. The monthly data for inflation and interest rates from January of 1995 to December 2020 were sourced from the online statistical database of the Bangko Sentral ng Pilipinas. The inflation series is the headline inflation with 2012 as base year, and the nominal rate of interest is based on the 91-day Treasury bill rate. Results and discussion. Table 1 provides the descriptive statistics. The 91-day Treasury bill rate and inflation have mean values of 5.66% and 4.56% respectively. Obviously, the 91-day Treasury bill rate show more variations as depicted by the value of its standard deviation at 4.27, compared with a more stable inflation with standard deviation of 2.41. Besides the skewness of inflation, which is 0.54, and the kurtosis, which is 2.72. The Jarque-Vera statistics reject the null hypothesis of normality at 1% significant level. Figure 1, on the other hand, shows the trend of the 91-day Treasury bill rate and inflation from January 1995 to December of 2020. For correlation diagnostics, the degree of association between the 91-day Treasury bill rate and inflation was calculated and further supported by the scatter diagrams and box plots as shown in Figure 1. The corresponding correlation pattern indicates some form of positive linear association between the 91-day Treasury bill rate and inflation. The correlation coefficient of 0.70 suggests strong positive association. It is expected, therefore, that increases in the inflation will lead to increases in the 91-day Treasury bill rate. All things being equal, a rise in inflation rate will eventually cause a rise in the 91-day Treasury bill rate. We estimated the equation where we regress the 91-day Treasury bill rate on inflation and obtained the results in Table 3. The t-statistic for inflation is 17.16 with probability value of 0. We say that inflation, therefore, is statistically significant at 1% level. The R-squared value suggests that about 49% of the variation in average 91-day Treasury bill rate is explained by inflation. The F statistic of 294.50 is highly significant as the computed probability value, which is equal to 0. The conventional Engle-Granger 1987 test results of bivariate cointegration between the 91-day Treasury bill rate and inflation is presented in Table 4. The Engle-Granger 1% critical value is negative 3.98. Since the computed t-statistic of negative 4.37 is much more negative, our conclusion is that the residuals from the regression of t-bill on inflation are 1, and that is stationary. Thus, the coefficient of 1.24 in Table 3 represents the long-run coefficient. In other words, the cointegration between the 91-day Treasury bill and inflation implies long-run Fisher effect or stationary linear combination. Likewise, as indicated by the computed cointegrating regression Darwin-Watson value of 2.02, suggests that the 91-day Treasury bill rate and inflation rate are cointegrated, thus reinforcing the findings on the basis of the Engle-Granger tests. There is a strong evidence that the nominal interest rates and inflations are co-integrated, and the path of adjustments to the long-run equilibrium must be 1-for-1. Following Johansen and Joselius 1990, in the long run, a 1% increase in inflation will lead to a 1.45% increase in the 91-day Treasury bill rate. This estimate appears encouraging, as it is not very far from the most traditional interpretation of the Fisher hypothesis, which suggests the co-integrating vector of 1:1. Therefore, the null hypothesis of B, which is equal to 1, can be rejected, providing no evidence of long-run full 1-for-1 Fisher effect in the case of the Philippines, covering the period of January 1995 to December of 2020. Having ascertained that the co-integrating relationship exists between both the 91-day Treasury bill rate and inflation, the final step is to verify if inflation grandeur causes nominal interest rates. The results of the pairwise grandeur causality test are reported in table number 7. With 3 logs at 10% level of significance, the test suggests that causality ran from inflation to the 91-day Treasury bill rate as posed by Fisher hypothesis. Likewise, we see that the 91-day Treasury bill rate causes inflation at 1% significance level. These findings point to a bidirectional causal relationship, which means that in the long run, there is no need to impose strict control on both variables. In conclusion, the correlation coefficient suggests strong positive association. Likewise, regression estimates convey significant positive effect of inflation on the 91-day Treasury bill rate. The outcomes of the co-integration tests provide support for the long-run Fisher hypothesis. However, results show the absence of the long-run 1-for-1 Fisher effect. The causality test demonstrated the bidirectional causal relation between the 91-day Treasury bill rate and rate of inflation. Thus, we can conclude that the predictability of nominal interest rate relies on the variations of inflation rate. That's all. Thank you very much.